this is your engagement coach, Marla Poisson, and today I'm going to be showing you a lab that can be used in your Science 8 Optics and Vision unit. It is designed for the reflection of, it's called the Reflection of Light Lab. Lab is designed to investigate one of the laws of reflection as well as to discover some of the properties of the image formed by a plane or flat mirror. So to begin, we need to collect some materials. Of course, the very first thing you need is a plane mirror, one that's rather large and will go across an entire 8.5 by 11 piece of paper is ideal. You'll also need some pins. I like to use different kinds of pins or pins like this that have large colors on balls on the end because they're easier to see. But one of my favorites is also using these dissection pins because they are nice and tall and they just work really nice. The other thing you can do, of course, is to combine them because it makes the easier to see. You will also need a ruler and a protractor. And then something to stick the pins into. So we are just using some layers of cardboard here. You'll probably need to use 2 or 3 layers just to make sure you get a really good stick in there. And or if you have something that's designed, foam core works really nice, or old ceiling tiles work excellent. So you're going to need that for materials. Lastly, you will need something that will hold the mirror in an upright fashion. And there are specific holders you can get to put on the sides of the mirror. But if you don't have those, regular binder clips work really nicely. And then if you stick them on the sides and push them all the way to the bottom, that will hold your mirror just fine. So the very first thing that we're going to do then is we're going to look at our procedure. So the procedure for this lab is not difficult, but it is picky. It's one of those labs that the kids will say, I don't understand. But if you follow the steps along, it really is quite simple. First thing, you need a 8.5 by 11 sheet of blank paper. And we're going to fold that sheet in exactly in half across the length so that you have a line that runs horizontal across the page. When you open that up, you're going to want the kids then to grab a pencil and just draw that line across there. That is going to be our plane for our plane mirror. So there we go. And that's the first step. Shockingly, even this step can be messed up, but because it is a sheet of paper, we just start again. As we're going through the procedure, I'm going to actually step back a little bit and move the camera, so you'll find that I'll have to stop and start a few times. That's just because there's going to be some details that you'll want to see. So right now, we have a line across the middle of the page, and we're going to label that AB. So that is our reflection line. And I'm going to turn this so you can see that a little bit better. Now we're going to take our mirror and we're going to place the mirror vertically along line AB. Ensure, these are a few things to worry about. Ensure that the mirror itself is exactly on that line. but it doesn't necessarily, and that it's pushed all the way down so that the glass is all the way down at the bottom there. There we go. Okay, so you can see it standing there with my binder clips and it's working just fine. What we're going to do is the first step in the lab is to just put a small object in front of the mirror and have them record some observations. Now, at this stage, you're not doing any calculations. You just want them to try to explain what they're seeing, because the laws of reflection, of course, are intuitive, but not self-explanatory. So if I put my object here, and you in the image can see exactly what I'm seeing as well. So they're probably going to say things like, it looks like a tomato. Exactly. But we're also going to ask some questions. Is it the image that they see in the mirror exactly the same as the object? And they should note that the left side in the object is actually the right side in the mirror, and vice versa. However, the top in the object remains the top in the image. And so that's one of the laws of reflection, that left and right are reversed, but up and down stays the same. They should also notice, and they may or may not notice that the distance, and we're not measuring, we're just observing, the distance from the object to the mirror seems to be the same as from the mirror to the imaginary object within the mirror, or in this case, the image. And that will be, again, something that we're going to look at, but maybe something they'll notice here. They could notice things like rotating one direction in the mirror, it seems to rotate in the opposite direction. So if I rotate in a clockwise direction here, that the image moves in a counterclockwise direction. They may notice that movement, again, one direction is reversed, but that up and down stays the same. They might notice any sort of observations. Remember, this is the time that we're doing qualitative observations, not quantitative observations. So anything that they notice and put down is fine. And once they're done their recording, then you just take that object, put it to the side, and we're going to move on. Okay, now we're going to move on to when we're actually going to do some quantitative measurements. First thing that we need to do is we're going to take a pin, and we're going to place it about 10 centimeters in front of the mirror, and that's going to be our object pin, and we're going to label that O. Grab another pin. You're going to see that I'm using a different type of pin now. And we're going to, anywhere over here, you're going to put the pin in to the left of your object pin. So there's my pin, and we're going to label that C. Now this is where it can get a little complicated. And it's not that it's hard. It's hard for the kids to see. So I'm going to move the camera, and I'm hoping I'm not going to give you vertigo as I'm doing it. But I'm going to move this at the same time as I'm going to move the camera. What you're going to want to do is they have to now look into the mirror. So I'm going to do that with this camera. Sorry. And see what we can see here. All right. So now we're looking into the mirror, and you can see all the stuff behind us here, which is going to make it look a little complicated. But what we want to do is to be able to see this pin, but you can also see into the mirror, you see that pin in the mirror. And that's the hardest thing for them to figure out, is that that's what we're trying to look at. We're not looking at this pin, we're looking at the image, the imaginary pin that's inside the mirror that you can see just over top of my real hand. What we have to do now is you're going to line up in the mirror, just like we would, you line up 3 points to make a line. We're going to do the same, but the third point is going to be that imaginary object in the middle. So I'm going to line up my camera now. I'm going to line up the real pin here with the imaginary pin. I'm going to do that with your camera as well. With the imaginary pin way back there in the mirror. You have to really get your head right down to the table. And so you see the pin in there with the red top, my pin here, and somewhere out here. It doesn't even have to be on the paper. I'm going to line up and I'm going to poke my pin in. Okay, and I don't know if you can see that very well. Oh yeah, it's actually not that bad. In fact, looking at the camera, I can see I'm a little off. So I'm going to move that a little bit to this way. Line up my camera again. See how that's looking. Push it in. And now just stand back and check. Make that line of sight from the 2 pins that are objects, but they're not objects. They're just us lining up to that imaginary pin in the mirror. And if you look at the camera, you can see all 3 of those pins line up. And so I'm going to call this point D. Now you'll notice point D is way off the page. It's in but it doesn't matter because I just need it for a point. So let's do the same thing. Keep our object pin. Now I'm going to put another pin to the right of there. And again, don't make them, it doesn't matter where it goes. So I'm going to do this one a little bit narrower angle, just so you can see. That doesn't really matter. You just want something that's going to stay on your page, though. If they get way out here, then of course we know that the object, it's going to end up being a line way out here, and they're going to run out of paper. So I'm going to twist this again. Hopefully I don't give you vertigo. And again, let's do the lining up. Right. So you're going to have them drop their head down right to the page. Line of sight from the new pin in through, we're going to call this E. Sorry, better label that E. From the new pin we just put in, we can see its reflection in the mirror, but we can also see the object's reflection in the mirror. That's why I like to have a different color. We're going to put our head straight down, and again, I'm going to line this up. This time you can see me in the camera. And again, it doesn't have to be on the page. I just want to line up my new pin, the existing pin E, and the object in the mirror. So it's an imaginary object. Now I have them fairly lined up. I'm going to check the camera. Oh, it looks really bad in the camera. Maybe if I move my camera over. There, you can kind of see in the camera here how the new pin, the existing pin E, and the object in the mirror make a line, because you need 3 points to make a line. And then we're going to label that F. At that point, we can remove all these pins, and what we're going to be doing is to be working with the data that we now have. All right, so now we're in analysis. You see that all I've removed is the the mirror so that we have more room to work with. And what we're going to do is we're going to remove the mirror. Don't remove the pins. The pins are actually really helpful at this stage. And what we're going to use is we're going to use them as a way to connect some lines. So we're going to draw these lines CD, connecting the two lines CD here. And that's, you can see how useful they are because we can push our ruler right against them. So there's the line CD. And just continue that all the way behind the mirror, or behind our line AB, which I have to relabel. And we're going to do the same to EF again, all the way behind the mirror. And we're going to label that point where the image was located as point I. Okay. Now, where our line CD meets our line AB, we're going to label that as P. And where line EF, and they're starting to come out, so I'm just going to take that out, intersects line AB, which we're going to label that as Q. Last thing that we want to do here, and I'm going to just remove these now because we've got all the points on our lines. The last step is we're going to make a line directly from O, where our object is, to I, where our image is. Now at this stage, you want them to try to be as precise as they can. You can see I'm using a Sharpie, really, really pointy pencil though, because like I said, it's not a hard lab. It's just picky. We are measuring light and the way it reflects. And now what we have is we have everything we need. We can remove our point, and now we have everything on the page. Okay, this is where the analysis comes in. Using our protractor, we're going to draw a perpendicular at point P. So we all know how to use that perpendicular, but the kids might need a little help here. We're going to draw a perpendicular at point P and at point Q here. Try to be, again, as picky as you can about its location. These aren't the best protractors in the world. Here's our Q. And this will be X and Y, just to give it a designation. Now we go on to the analysis. We are going to record the angles of incidence and reflections. So the last thing that you're going to need to do is we have to connect object O to the where it intersects P. So OP comes a line, and O, object O, and point Q also becomes a line. You can see I was getting a little lazy there. The kids will be much more precise. Right, now we have our angles of incidence and reflection. Hopefully you've talked to them about this, because all we're doing is, this is the lab to either introduce them to this concept or to actually confirm it. Whichever way you want to use it is fine. And so this is a measurement point. I'm going to label these as alpha and omega, just because I like doing that, alpha and theta. And it just gives them something to measure. Or you could call it the angle of incidence, small I, and the angle of reflection, small r. That might be easier for them to do. So here, this is my angle I, this is my angle r. And so I have an angle of incident and reflection from OQY, and I have an angle of reflection from YQE. On the left side, I have an angle of incidence from OPX and an angle of reflection from XPC. So now we have all of our angles. And we're going to do some measurements now. Okay, now the kids can put all their pins and everything away and make sure that their space is cleaned up. And you can do this. Can have one person doing this, especially if you're working in groups. This will be like Marla's page, and then you have somebody else go and make their own page. It is really good to work with a partner, but a lot of the measurement really has to be your own. And you can only have one person viewing at a time. This is a good way to have a lab that multiple people can be producing, working on the same area, but they're all producing their own page. So the first thing that we're going to do is we're going to measure the distance from O, our object, to H, where it intersected line AB. Remember, that's where our mirror was. And then from H to image I. Now, somewhere they're going to have to record this in the lab. I'm going to give to you the lab outline. There's actually all there. And so there is a place for them to record. So when you measure this, we want to measure in centimeters. They should very quickly see some patterns starting to arrive. So again, as precise measurement as you can. Oh, that's nice. So I have 9 centimeters here. And on the other side, ooh, I'm terrible at this. I have 10.6 centimeters. Okay, and again, like I said, make sure that they measure. Oh, I can schmooze some more space out of there. 9.3 centimeters. Okay, so we have our distance HI and HO, or OH and IH. The next thing that we're going to do is, again, grab your protractor, and we're going to measure these angles of incidence and angles of reflection for each of the sides there. So again, we're hoping that they have this ability. It doesn't matter whether you're measuring along a line AB or you're measuring this way. Just remember that if you're measuring along line AB, you're actually measuring the angle here, which is truly not the angle of incidence, and angle here. The angle of incidence comes from the perpendicular. And so it doesn't really matter what you do, though, because they'll be able to see the pattern. So I'm going to measure from the inside. And again, these are not really great, but I can see that is about 15. Oops. So 5, 10, 15, 16, 17 centimeters, or sorry, 17 degrees there. And when we measure on the other side here, I have about 19 degrees. Okay, doing on the other side. Your kids will be much more precise than I. This is 10 degrees. And this one is, oops, nice, 9 degrees. All right, so now we have our angles of O, if we go on this one, OPX is going to be 17 degrees, 19 degrees. OQY is going to be 9 degrees and 10 degrees. And then as you can see in the form here, this is your diagram. And then you also have to include your partner's information as well. And that's because we explained to them the more data you have, the more precise your lab will be. We can't count on data from just one experiment. We're always doing more and more and more. And so once we get, you could have all 4 of them, or if you have a group of 4, and you just keep including the data from that. Then once we have all this here, there are some questions to do, but we should have started to see some patterns. So you can ask them some questions like, did they see a relationship between the angle of incidence and the angle of reflection? Do they notice something about the distance between the object and the plane line of the mirror, and from the line of the mirror and the image? Why do they think that they actually should be exactly the same, but why do they think they're so close? So start to ask them questions. From this, they should develop the idea, the things that we want them to understand from here is that light travels in straight lines, always. It doesn't matter if we have the real light or the imaginary light that goes into the mirror, but it's always traveling in straight lines. From that, we also notice that wherever it's reflected, the angle of incidence, so when you're going from the object into the mirror, that light is reflected at the same angle it came in on in the angle of reflection. So the angle of incidence equals the angle of reflection, always. And we just keep practicing at that. So just to wind up, it's not a difficult lab. It doesn't require a lot of materials. All you need is some paper, some pins, and a plain mirror. What it does take is some patience and an ability to kind of think outside the box, because they have to think about looking into the mirror and thinking about where that light ray is going. It's not intuitive. And I have found that kids, even up to grade 11, struggle with this because of that idea of looking into the mirror for the image. But because it's one of those ones that once they get it, it really displays the idea of angle of incidence, angle of reflection, that the fact that size stays the same in a reflection. And so you're going to be able to pick out a whole bunch of those indicators just with this one lab. So I hope that you give it a try, and you know that you can always contact me if you're having any trouble. Have a good one.